Hello good day viewers. In this tutorial I'm going to provide a solution to this problem, which is cosine x raised to the power of sine x equal to 1. I've seen another version of this tutorial on Black Pen Red Pen channel where he solved sine x to the power of cosine x to be equal to 1. So I want to give this a try. So on what condition will this statement be true? We know that if the exponent is equal to 0, definitely this raised to the power of 0 will be 1. So this is the first condition. We have if sine x is equal to 0, this will be true. No doubt about it. And of course, if the base is equal to 1, 1 raised to the power of anything will still be equal to 1. So if the base, which is cosine x, is equal to 1, this statement is true. And another way is when the base is negative 1, that is when cosine x is equal to negative 1. But this time around, the exponent has to be even. And you know that from the domain, this cannot exceed 1 and it cannot go below negative 1. So the domain is between negative 1 to 1. Therefore, we are not going to consider this case. So these are the two cases we have, and we are going to provide a solution to these two equations separately. Let's start with the first one. The first one, I think, let me draw a unit cycle here. We know that the coordinate here is what? Negative 1, 0. And here we have 1, 0. Here we have 0, 1. And here we have 0, negative 1. So what about the angles? You know, this is pi. This is pi over 2. This is 3 pi over 2. And this is either 0 or you can call it 2 pi, a radian. So now let us consider this one. The first one, when you have a sine x equal to 0, we want to find out where y coordinate is equal to 0. You can see this is a y coordinate. This is another y coordinate. So when you have your angle to be 0 or pi, you're going to get 0 definitely. So sine of 0 or 2 pi or pi will give you 0. So the solution to this problem, x is equal to pi, multiples of pi, because from 0, once you add pi, you get to this one. You add another pi, you get to this one. So we can decide to say this is just another multiple of pi. So we say that this is pi k, for which k is an integer. It could be 1, 2, negative 1, in that order. Okay, we have provided a solution to this one. Now what about cosine x? You know, cosine depends on x coordinate. So we want to find where cosine is positive 1. So I think this is the only place we have positive 1. So this is just another multiples of 2 pi, because from here, if you add 2 pi, you're going to get back to this one again. Keep on adding 2 pi. So for cosine x equal to 1, x is just a multiple of 2 pi. For which I told you k is just an integer. As simple as that. And if you like, you can test them in the main equation. Let us consider this pi first. If you plug in pi here, you have cosine pi here, and cosine of pi is negative 1. So you can see that we have negative 1 raised to which power? Sine of pi. Sine of pi is 0. And you see that negative 1 to the power of 0 will give you 1. And you can test this one. When you have 2 pi, cosine of 2 pi is 1. So we have 1. Sine of 2 pi is 0. 1 to the power of 0 is still 1. So it's satisfied. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.